This is Algebra 2 with trig. We're working on our second day of 14.1 and 14.2. We will be graphing sine and cosines with translations. Looking over our notes, we see that the a value of an equation, it's going to help us find the amplitude. And it helps us decide if there is a reflection. A reflection over the x-axis, or really a reflection over the midline. Some people might also say that it helps you determine if there's a stretch or a shrink. That might be another possibility of wording to have in a blank like that. The b value helps us figure out the period. To calculate the period, we would use 2 pi divided by b. Our graph will go in increments. The increments are the period divided by 4. So when we look at our translatable graphs, you have seen equations throughout the year with the same type of format. You've had a values in front of the function. You've dealt with the x and y. The h and the k. We'll translate it to the right h units and up k units. The one vocab word that's different today is called the midline. This is a horizontal axis which the graph of a trig function oscillates. The midline can be given by the equation y equals k. So whatever your k value is, you'll notice that that will be the midline. So let's get into our first example. So we're going to graph y equals 1/2 cosine of 2x. We're going to combine both of this. This has a shrink in it. We're going to combine cosine of 2x with the half shrink, all in one. Notice it has a b value. If it has a b value, then we need to calculate the period. The period is 2 pi divided by b. So this is 2 pi divided by 2, which is known as pi. So that means in our table, we're going to have 0, 1 pi, 2 pi, 3 pi, and 4 pi. All right, I just wrote my table incorrectly there. It ends with pi, of course. It ends with pi. That's the period. So we need to calculate the increments. The increments are the period divided by 4. So we're going to go in increments of pi over 4. So we have pi over 4. Then we have 2 pi over 4, which can be reduced to pi over 2. Then we have 3 pi over 4. And then we have 4 pi over 4, which is reduced down to pi. This is a cosine graph, so we know we start at 1, then we go 0, -1, 0, and 1. And we are multiplying by a half. So we're going to multiply all those y values by a half. So notice that we're combining what we did yesterday in 2 graphs. We're combining it into 1 graph today. You don't have to. You can do the cosine of 2x for 1, and then you can shrink it, and then you can translate it. Your choice. So we're going to come over. We already know that we're going by the scale of pi over 4, 2 pi over 4, which is reduced, 3 pi over 4, and 4 pi over 4, which is reduced. So that's a scale on our x-axis. We're going to plot our points. We'll call this 1. So we're going by halves, essentially. So if the regular cosine graph would start up at 1, but we're going to graph half of the cosine, so we're going to start at a half, and then 0, and then negative a half, and then 0, and then positive a half. That's the graph y equals 1/2 cosine of 2x. That's combining two graphs of what we did yesterday into one graph here. Because now we're going to take this result and notice that we have this extra portion to our equation. We have this minus 2. Notice there's no parentheses, so we know this is a k value. This is going to translate the graph down 2 units. So every one of these points, remember, each line is a half. So we have a half, 1, 1.5, 2. So we went down 4 lines. 1, 2, 3, 4 lines down is translating it 2 units down. And we can graph it right in there. We would draw our midline. Our midline used to be at 0, and now it was translated 2 units down, so we are at y equals -2. That is our midline. The amplitude is a half. The period is pi. And the midline is y equals k, so that is y equals -2. Okay, on the flip side, we're looking at a sine graph. Notice it has a b value. So if it has a b value, we're going to be calculating the period and increments for this graph. Notice that I have the a sine of bx. We're going to do that all in one graph. Then we're going to translate it 3 units, 3 pi units actually, to the right. It's always the opposite of what the sine looks like. So the period is going to be 2 pi divided by b. So in this case, that's 2 pi divided by a half. And whenever you have a fraction in a denominator, you have to multiply it by the reciprocal. Multiply the top, the numerator, by the reciprocal of the denominator. That gives us 4 pi. That helps us determine the increments, which is known as the period divided by 4. So our increments are going to go by pi. So looking here at our table, we're going to start at 0, then we go pi, and then 2 pi, and 3 pi, and we know that the amplitude was 4 pi. And not the amplitude, I'm sorry. We knew the period was 4 pi, so that's always going to be our last box. So that worked out perfect. The sine graph always starts at 0. It goes to 1 and then 0, then -1, then 0. And because the a is involved there, the a is going to multiply all of those by 2. So we'll come over to our grid. We know our scale is going to be pi, 2 pi, 3 pi, and 4 pi. We should be able to adjust our scale a little bit here and count by halves. That will just spread it out a little bit more. You have to be careful of your k value. We don't have a k value with this. There's no value after the parentheses. So we're at 0, then we're up at 2, then we're back to 0, then we're down to -2, then we're back to 0. Notice that we're doing both our graphs from yesterday in one. You may break them up if you wish. Y equals 2 sine of half x. Now what are we going to do to that graph? Looking at our equation, we have dealt with every part except this h value. We see that we have an h value that's called 3 pi. The formula is x minus h. So if the equation says x minus 3 pi, then the h is 3 pi. It has a horizontal translation of 3 pi to the right, positive 3 pi. So that means every one of these dots is going to go 2 lines, which is 1 pi, 2 pi, 3 pi. 1 pi, 2 pi, and 3 pi. And then we can graph that back in. And we have translated it 3 pi to the right. So we have 2 sine of half x minus 3 pi. The x minus 3 pi has to be in parentheses, not the 2, not the 1/2. The b value is always outside those parentheses. Our amplitude is, of course, 2. The period we calculated is 4 pi. Even after the translation, it's 4 pi. If this is 3 pi and 4 pi, this line would be 5 pi, 6 pi, and 7 pi. Notice that it takes 4 pi to get from the beginning of the cycle to the end. And the midline did not change. It is still y equals 0. Here's number 3. We're going to do y equals negative cosine of 4x. That's going to be the first graph we do. This value, notice, there is no parentheses. So I know that my k value is 1. That's what that plus 1 means. So the period is 2 pi divided by b, so that means the period is going to be pi over 2. And the increments, how we work across the scale for the x-axis, is going to be the period divided by 4. To do that, you multiply by the reciprocal. So we're going to count by pi over 8. So if we start at 0, then we're going to have pi over 8, and that's 2 pi over 8, which means pi over 4. 3 pi over 8, and 4 pi over 8, which is pi over 2, which is what we said the period was. Cosine starts with 1, goes to 0, then to -1, back to 0, and 1. The A value is going to multiply all of those by -1. So this is going to be reflected over the x-axis. So we can come over to our grid. We can put in our increments. So we know we're at pi over 8. 2 pi over 8 was reduced. 3 pi over 8. And 4 pi over 8 was reduced. We can still go by a scale of a half, which means 2 lines for 1. And if we're going to just graph one of these, notice we're going to start with the -1 at 0. And then we go to 0, then we go to 1, back to 0, back to -1. So this is y equals negative cosine of 4x. Then we're going to take every one of those points and translate it our k amount. So move all of those up 1 unit, which happens to be 2 lines. Remember, when you draw it, try to draw it so it's not like shark teeth. Try to curve it through there. That's going to be y equals negative cosine of 4x. We don't use parentheses here. Plus 1. If there were parentheses, we would imply that the 1 would be the h value. And we should put our k value in there. Our midline, y equals 1. The amplitude is 1. The period we know is pi over 2. And the midline was y equals k, which is y equals 1. Okay, number 4. Notice that number 4 has an h value. This says plus pi, so that means we're actually going to go 1 unit to the left. 1 pi unit to the left, actually. And this is the k value, which is 1, which means we're going to translate it up 1. There is no b value. There's no value in front of the parentheses. So that can help speed things along. We know we're going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So here we're going to first graph y equals 5 sine of x. So sine uses 0, 1, 0, -1, and 0. And then the 5 is going to multiply that by 5 times as much. So when we come over to our grid, we can put in our increments. We don't have room to stretch it out at all, so we're just going to have to count by ones. We can start out at plotting at 0, and then 5, and 0, and -5, and back to 0. Try to curve it the best you can. So that's y equals 5 sine of x. Try to make it touch those points. Now we're going to translate it. We need to translate it to the left pi and up 1. So to the left pi, remember each line here, each unit, each increment is half a pi. So we're going to have to do 2 increments to the left and 1 up. 2 increments to the left and 1 up. And there's your graph. So this is y equals 5 sine, we have parentheses this time, x plus pi plus 1. So the amplitude is the absolute value of your a, so it's 5. The period, we calculated that. We could have calculated that, but we know that the b value was 1, so it was just 2 pi. We can see that from here. If you look closely, we start at negative pi, and we go all the way out to 1 pi. So that's a distance of 1 pi, 2 pi. And the midline, I didn't draw that in, so that helps us remember that we should put a dashed line through there, which is y equals 1. There was no or none for a reflection. That's the R, none for a reflection. We have a stretch by factor of 5. And we had a translation. Pi units left and 1 unit up. That's what the RST is asking. What is your reflection? What is your stretch or shrink? And what is your translation? We went to the left pi and we went up 1. Number 5. This is the cosine. Y equals negative cosine of x. There's no b value, so there's no need to recalculate a period. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is a cosine graph, so we start at 1, and then 0, -1, 0, and 1. We multiply it by the a value, which would mean -1, 0, +1, 0, and -1. Multiply all your y values by the a. So when we come over to our graph, we put in our increments, which is pi over 2. This is your standard. 3 pi over 2, and 2 pi. We see that there is a stretch. There's no additional stretch actually, but there is a translation. Our k value means it's going to go down 2, and our h value is going to move to the right 1. So just trying to figure out my scale here. I think I can go by, if I go by 1, and I got to get to 3 total, so I think that'll work. So 1, 2, and 3, negative 1, negative 2, and negative 3. So cosine, we're going to be at negative 1, then we're at 0, then we're at positive 1, then we're at 0, and we're back to negative 1. So that's the graph y equals negative cosine of x. And then we're going to translate that graph. We're going to translate it 1 unit, or actually pi units to the right and 2 units down. So that's 2 units, which is the total length of pi, and then 2 units down. So we have our new dots. We try not to make them look like shark teeth. Curve them. And this is y equals negative cosine. And we use parentheses. X minus pi minus 2. Our amplitude is the absolute value of a, so it's just 1. The period we determined was 2 pi. The midline is y equals negative 2. That helps remind me. I need to put my midline in here. So that's y equals negative 2. I have a reflection over the x-axis. I do not have a stretch or a shrink, so none. And I have a translation, pi units right and 2 units up. That would be down. We went down, the k value is negative, of course. Very good. As our scale, our increments were working out to the period, we could continue this. This was pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. This line would be 5 pi over 2. This would be 6 pi over 2. So it just continues the distance out. And if you notice, if you start at pi and you're finishing at 3 pi, that is still a total period of 2 pi. From 1 pi to 3 pi is a total period of 2 pi. Last example, then you have 2 that you can try. So this is y equals negative 2 sine of x. There's no b value for this, so it does speed things up a little bit. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. A sine graph goes by 0, 1, 0, negative 1, and 0. And we multiply by negative 2. So we can come over to our graph. We have our typical scale. we have some translating to do, so we do have to be careful about our scale. We'll have to go units of 1 at a time. And our sine, we start at 0, then we went to -2, because remember it's reflected because of the negative a. We're graphing all of that into one graph. So this is y equals -2 sine of x. Then we're going to translate that. We have an h value that is negative pi over 2 and a k value that is 3. So each one of these increments was pi over 2. So moving to the left was negative pi over 2. So we move to the left pi over 2 and we go up 3 lines. Graph it in, write the equation. We have x plus, which means to the left, pi over 2, plus 3. Try to make that fit. So our amplitude is the absolute value of a, so it's 2. The period we still know is 2 pi. And the midline, which we should graph in here, which is y equals 3. It's always the k value. So we have a reflection over the x-axis. We have a stretch by a factor of 2, and we have a translation pi over 2 left, 3 units up, and it is up this time.